Welcome everyone to the discussion of Book 1, Proposition 10. It says to bisect a given finite straight line. So everyone, this is another construct proposition. It shows how to bisect a given straight line into two equal parts in general sense. And when we say finite, it means a component with boundaries. Hence, it is not extending without an end. And we are citing this proposition when we need to divide a line into two equal parts and proving other propositions. And as an overview, in order for us to be guided on how we're going to construct the figure and how we're going to prove it, then here are the components. So we have the construct of the equilateral triangle. So that's at proposition 1, definition 20. And we also have, of course, proposition 9, how to bisect an angle. So this is the biggest part of the proof also, having two equal angles. And lastly, the parameters of two congruent triangles. Contained angles and sides are also equal to its corresponding angles and sides. So that's at proposition 8. And in creating the figure, here are the detailed steps. So we will just follow them step by step, okay, and we'll discuss the proof later. So please join me as I draw the figure. So let's do that together. So the first one is to draw line AB here, okay, and we will now create an equilateral triangle by having circles A and circle B. So let's do that, and we'll have radius AB. So circle A, radius AB, and circle B with radius AB. And observe that there's a point of intersection here, and we'll name this point as point F. Okay, so now let's create an equilateral triangle. Okay. Then this point C somehow is a starting point for the line that will bisect our initial line AB. So let's now bisect AB, and the point of intersection of line that would bisect AB is point B. So we have line CD bisecting the initial line AB. So how are we going to show that indeed line CD bisects AB and that AD is equal to DB? We cannot use side-side-side theorem, so because again, we need to establish equality between these two, this pair of sides here. However, we just bisected the big angle ACB by having line CD here. So we have two equal sub-angles, ACD and sub-angle DCB. Okay, so we can then use the side angle side theorem. So we have the first pair of equal sides, AC equal to side CB. And also side CD is equal to itself. And again, by having sides or line CD here, bisecting the angle ACB, then we have two equal angles, ACD and DCB. So side angle side. Hence, we have just presented that the triangle ACD is congruent to triangle DCB. And again, by having two congruent triangles, then we can say that the remaining sides and the remaining angles contained in the triangle are also equal. Therefore, the sides AD is then equal to side DB. So we have just shown and proven the proposition 10 that guides us on how to bisect a given finite straight line. So thank you so much for watching and listening, and take care.